Welcome to a lesson with Dr. Powell. Let's take a look at solving an exponential equation. Okay, we're going to use logarithms because logarithms extract things. We can use log base anything because the exponents are going to be extracted. See how the variables are in the exponents up here? So it doesn't really matter which base we use. We could use a base that matches one of the bases we see, either 2 or 5. That might help with the computations a little bit. Why don't we choose log base 2? So let's apply it to both sides. Log base 2 of 2 to the 3x plus 1 is equal to log base 2 of 3 times 5 to the x minus 1. All right, now it's time for properties. Notice how you see this exponent? It's extracted. It comes out up front by a log property as multiplication. So we get 3x plus 1 times log base 2 of 2. And that's going to be equal to, now let's use some properties here. See this multiplication? It'll become log base 2 of 3 multiplied by, or added rather, sorry, the multiplication right here turns into addition. Multiplication on the inside is addition of the exponents. So plus, and then we have log base 2 of 5 to the x minus 1. Now we can send this x minus 1 out front here. So writing that down, replacing this, we can think of this as simply being x minus 1 multiplied log base 2 of 5. Great. Now, notice how we use log base 2 of 2, or we're using 2 and 2 here. That's nice because 2 to what power is equal to 2? It's 1. So this is just 1. 2 raised to the 1 is 2. So this is 1 right here, which is great for this side of the equation because this side of the equation simply just becomes 3x plus 1. And over here, we have all this. Now let's just think about what we're after. We want to solve for x, see what x is. Now, in order to do that, we need to isolate x. So it'd be good to distribute this guy in here and here, so x really comes out in the open. Now, another thing to remember is this is just a number. It looks scary because all this symbols happening, but it's just a number. I mean, if it does look too scary, just replace it with something like 5 or 7 or something. Let's do 7. And this one over here, you just think of it as a number. Just replace it with 1 for a minute, all right? And then really, this is all it is. It looks like it's something more scary, but really, this is all it is. It's something like this. This is a number, like 7's a number. This is a number, like 1's a number. So you just solve this as you normally would. Of course, it's not 7 and not 1, so you'll have to replace back in, but why don't we just do that for a minute and see what it's like? So this is like 7 times x, because it multiplies into the x, it multiplies into the -1, minus 1 times 7, right? And then we have plus 1 over here. Okay, so we're going to do something very similar to that now with what we really have. It's going to multiply it in. Okay. So we end up getting log base 2 of 3 plus x times log base 2 of 5 minus log base 2 of 5. We just distributed that in. This is what we have so far. We want to isolate x, so we better move all the x terms over. Remember, if log base 2 of 5 is like 7, this is like 7x. You have 3x over there. What would you do? Well, you'd subtract 7x from both sides, put it over here, and combine like terms. Well, that's exactly what we're going to do. This is a like term with this. We just simply need to add coefficients or subtract coefficients, which is the same thing as factoring out x. Combining like terms is nothing more than factoring what's common, what's like. This is another way of saying it. We think of it as combining like terms, but it's really just factoring out what's like. If the coefficients are easy to add, we ignore or kind of forget the fact that we're really factoring, but That's really what we're doing. But we have to go back to that when we see coefficients that don't seem to add nicely. However, it's done the same way. So let's subtract this over here. So we get 3x minus, and I'll write the log base 2 of 5 in the front of the x, so we can think of this as a number times x. Now this 1, let's move it to the other side. Minus 1. This remains over here, log base 2 of 3, and we still have minus log base 2 of 5 over here. All right, so how are we going to find x? We got to isolate it. We see two instances of it. Remember what we said? How do you get 1x? You factor out what's like the x. It's like you're combining like terms, just adding the coefficients, but the coefficients don't seem to look too nice when they add, yet that's all it is. And that's what we need to remember, what's really going on. So this is log base 2 of 5. So this is 3 minus log base 2 of 5 as the coefficient is equal to all of that. So in the end, in order to get x, you would just simply divide out by this coefficient right here. Just divide it to both sides. So we end up getting x is equal to this guy divided by the coefficient of x here. So -1 plus log base 2 of 3 minus log base 2 of 5 all over 3 minus log base 2 of 5. Now, this is the result. We could maybe plug some things in the calculator to get a decimal approximation. However, for work here, just to kind of verify that we're doing things the right way and actually learning the process and the steps, I would like you to focus on writing this completely out in an expression like this in order to figure out what x is equal to. There are ways of simplifying this expression, but let's not worry about that. I at least just want you to be able to get the right result here in solving for x, in understanding how to combine like terms when it looks kind of funny and how to divide over. Thanks for watching.